In this slide, we will examine the following A and given B, and using this equation over here to find x hat, the x that will give the least square solution. This example can be approached mechanically. Simply, we will find A transpose A first. Basically, given A, we will find A transpose, which is rotating or tilting the columns of A into rows, like so for A transpose. Once we have found A transpose, we can multiply by A to get A transpose A. In this case, A is a 3 by 2 matrix. A transpose A would be a 2 by 3 matrix multiplied by 3 by 2 matrix, giving us a 2 by 2 square matrix. A transpose B is a 2 by 3 matrix for A transpose, and B is a 3 by 1 vector. Therefore, it will result in 2 by 1 vector, as shown here. Once we have A transpose A, we can plug it into here. We have A transpose B, we can plug into here. Now we are ready to solve for x1 and x2. All we need to do is to apply this equation here. Basically, first we have to find A transpose A inverse, and because this is a 2 by 2 matrix, we can use the famous formula for the invertible or inverse of a 2 by 2 matrix. We can plug all this in, and we get solve for x hat equals to half. Oh, sorry. First entry is 1, second entry is 2. Now, this example reminds us that in this example, A transpose A is invertible, but this is not always the case, and we always have to check. Let us now use a figure to interpret. The columns of A are R3. There are 3 coordinates. The first coordinate is x1. The second coordinate is called x2, and the third coordinate is called x3. In this figure, we have x1 over here in this coordinate, and over here we have x2 in this coordinate, and the vertical coordinate is x3. Let us draw the vectors associated with column 1. It is this one. 4 along x1, 0 along x2, and 1 along x3. The second column of A is here. 0 along coordinate x1, 2 along coordinate x2, and 1 along coordinate x3 here. Once we have drawn the first column and the second column, any linear combination of these two columns fills up this blue plane. This is the column space of A. Using the normal equation, we have solved x hat equals to 1, 2, implying the first column of A is 4, 0, 1, 0, 2, 1, multiplying by 1, 2. Means that 1 is multiplying by the first column, 2 is multiplying by the second column, and we add it up together. This is AX hat. And where is AX hat? You can work it out, and the answer is 4, 4, 3, which is this point over here. Now, if we use this x hat, by multiplying by the first column, we have reached this point, and 2 multiplying by the second column, we are basically asking us to go 2 this way, 1, 2, 2 along the second column, and we will reach ax hat as well using this interpretation. If not, we can compute it by brute force and we get this value. We have found ax hat here, a point in the blue plane which is in the column space of A. But where is B? B is sitting not on the plane, and therefore there is this dashed line that is connecting from B to ax hat, and we call this the vector E, which is B minus ax hat is equals to E. And we have calculated in this example that the error is square root of 84. We'll show that in the next slide. All we need to do is to plug in x hat here, given A, and therefore we'll have B hat, which is equals to A multiplied by x hat. B minus B hat would be the error vector. This is B, and this is B hat. The error vector is this value, and you can try it for yourself. The error vector is orthogonal to all columns of A. So if you try minus 2, minus 4, 8 versus the first column 4, 0, 1, you will see that the answer is minus 8 plus 0 plus 8 is equals to 0 for the first column A1. You can try it for the second column and you will get the same. In fact, you can find any linear combinations on this blue plane and it will still be orthogonal to E, the error vector. These slides also show one more point. Once we have the error vector, we are interested to find its length, which is taking the norm of this, and the norm of an error vector is nothing but square root of the inner product, which is square root of minus 2 times minus 2 plus minus 4 times minus 4 plus 8 times 8. And the answer is square root of 84. The length of the dashed line is square root of 84, showing us that this is the best that we can do, and there is still an error of square root of 84 unit from A hat x hat to B.